All right. So the first thing we got to start off is to import all the libraries. That way everything could run. And at the bottom, we had to put one of the things where it could detect the errors, which we would technically like use later. So it's just nice to have it in the beginning. Now, when it comes to actually storing like or importing the data, we had to get the concrete data XLS file. And with that, we had to, well, first we got the table and then we got the categories of it. But I mean, it was too long. Like, we're not going to put a cement component 1 kilograms and, that. So we shortened it down to what was in the other one. And it was just cement, blast slag, fly ash, just to, have new names for the frames. And then we put head just so we could actually see the table and have like a rough idea because the little range was there. And then obviously we just gotta describe what's going on, which is why we put that. Now the next part, if we scroll down more, so you can see this part first. For that we had a little bit of trouble. That just explains what each one does in the rows and the categories, so we can visualize it more. And then if you keep scrolling down, that's where it's going to show us the heat map that we made for the concrete. This is so we could actually show us the actual difference between each of the combinations. That way we could actually see which one's the best option relatively quickly. We also chose green because if you know, like, night vision is chosen green just because we could tell the colors apart. But yeah, that's why we chose that. And then we just we copied the data for the selected variables into the data frames. That way we could just keep it there. Now for model, All
right. So, so after that, like, we found out like which variables are like not interrelated that much and are like affecting the cement strength like the most. So we chose them out: the cement, the age, and the superplasticizers, and we started creating models using those variables. So, like, firstly, the first model we created, we named that model A. That was like using the linear model thing, and we using just the single variable cement. We imported the library. We renamed that as SMF. Let me go back and show that. That was the stats model, the .formula API. We used that to do the fitting. For the model A, we did the fitting between the strength and the cement. The data was the data was in the DF data frame. After that, we like doing the things which we do for creating a model. We stored the predicted value into ypredict. Was something? And the parameters in beta 0 and beta 1. After that, we went on to plot the actual data alongside the data that the model predicted. We got the graphs like that. And we use the function we defined in the very beginning to calculate the error as well. That error is going to help us to find out which model is the best in the very end when we're going to compare these models. So that was that about the first model. Going to the second one, we did we used the same approach, the linear approach. This time we used cement, superplasticizer, and age to find out the cement strength and MPa. The very same thing using the SMF. We did the fitting, stored the value in Y, stored the parameters, and plotted everything all together, the data from the model and the actual data. And yeah, that was it for the model B. The same error calculation. We went into the model C. So we did two models from the linear part. Then we changed our approach. We went onto the power law model, in which we took the logarithm of the data. So in the very first one, we just used one variable. We were trying to see the relation between the cement and the strength. So we took the log of the cement data, the log of the strength data. We did the fitting again right over here. The very same things again, plotting the data like this. That thing is also done. The error using the error function. the we keeping the approach same, the power law model. We did that with two variables now, cement and age. Did the very same thing, took the logarithms, did the logarithm over here, and did the fitting in these two lines right over here using the same smf.ols. Saved the values, saved the parameters, and went into the plotting part where we did plot the original data alongside with the data from our model, set the titles, set the titles and the labels for everything, and went on to the show the whole graph. The error part again. And the model E was a quadratic model in which we took the variable, the cement variable, and used the quadratic approach. Again, we square rooted, my bad, not square root. We squared the data in the cement column, did the fitting the same way, but using that data which was squared. And after that, same thing, plotting the data against the data from the model against the actual data, found the error, and finally compared the errors of all the methods we used. We found out that the model B was the best, the model with like multiple feature linear modeling that came up with the least error, so we chose that one. Yep, correct. Correct.
There was the beginning of the table where the words were like mashed together. Yeah, yeah, that was a pretty big problem, but we worked around it and it helped us with it. Yeah.